hopefully, as you worked your way through and were able to expand all of these, you started to understand how the properties work, right? So I think on Friday we had talked about using the quotient property first, then we talked about using the product property, and then we talked about using the power property, right? We talked about using those three. But in this, what we should do, since this is the exact opposite thing, right? This is, instead of expanding, you're condensing. So this is the exact opposite thing. So since it's the exact opposite, it would make sense that those three things would flip. So now instead, we should use the power property first, then we should use the product property, then we should use the quotient property. I'm going to show you a couple examples that can make the quotient property kind of dicey. You remember how on Friday I gave you guys the a question and I said, okay, like 90% of you are going to get like a 4.5 out of 5 on this one. And then a lot of people kept getting the sign wrong. Like I said, this is probably what people had, and then everybody started nodding, and I said, this should have been a plus sign, and everybody's like, oh, okay, yep. So that's what the issue is going to end up being with quotients. A lot of people are going to fall apart when it comes to quotients. Those are the hardest part about this thing. When you're using powers and products, those are pretty straightforward. This thing right here is going to end up being a power. Now, I don't care if you simplify this, because a lot of you are going to try to simplify it, and I don't have an issue with that. If you don't want to simplify it, that's fine. But what I mean when I say simplify is using the power property, it will turn into something that looks like this. So using the power property, it will turn into that. Now, I don't care if you simplify that and call 4 squared 16. I really don't care. If you want to, great. If you don't want to, great. I gave you this problem more as a see if you can understand how the properties work, and if you get close, that's good. So if you called it 4 squared, that's perfect. If you called it 16, that's perfect. I don't have an issue. Now again, the next thing I like to do is I like to deal with my product property. So two things being added will then be multiplied. So I can then see that these two things right here are going to end up being combined. So those two things will end up being combined because we're adding them. So all I do is I combine them into one log. So I take x times 4 squared. So let's simplify it and call it 16. 4 squared is 16. 16 times x will give me 16x. If you called it x times 16, I don't have an issue with that. It doesn't make a difference to me what you do. Okay, minus the log base 3 of y. So now it's very clear that I only have 2 logs left. They're being subtracted. If I have 2 logs being subtracted, this is the same thing as division. So now all I have to do is combine it into one log with a single base. So log base 3 of 16x over y, and I'm done. Okay.
Wait, if you just do 2 log
2 log 3. So the only issue is when you do 2 log 3, or when you put the 2 in front of here, using the power property then, that means that this 2 would then have to go out here, which means that that 2 would then be distributed to every single thing on the inside. So you have to take care of that first. Yep. So I don't know if you guys heard Ashton's question, but he asked if it was possible to put the 2 out front.
Yeah.
And if you put the 2 out front and wait till the very, very end to take care of it, that means that 2 would then have to get distributed out into the set of parentheses, and then it would have to get distributed into the parentheses, which would then make every single thing squared instead of the one thing. So if you take care of it first, then it only squares the one thing that it's supposed to, not everything else. Good question. So I want to give you another one, and I want you to see how it works, and I want you to see if you run into the same issue that a lot of other people ran into. So if I have something like log base 4 of x minus 2 log base 4 of y minus 3 log base 4 of z. Now, one thing I want to mention right away is if these log bases are not the same, you cannot do this, okay? So I'm telling you right now, on your quiz or a test or whatever is coming up, I will give you a question where the log bases are different, okay? So I will give you one that says like log base 4 of x minus log base 5 of z. And then there will be people that say something like log base 20 of xz. So they try to combine them. You cannot do this if the bases are different. For the same exact reason that if I have something like x squared times y squared, I'm not going to call it xy, right? Or I'm not going to combine those if it was x squared plus y squared, whatever. I'm not going to combine those because I can't. I can't combine these unless the bases are the same. If the bases are all the same, that's great. If they're not the same, then you can't do anything with it. the thing that I will always say to you as you work through these types of problems is the quotient property is the most challenging, because the quotient property is the one that I think a lot of things will go wrong with. Okay, I'm going to show you two methods on this. One method is one that I think everybody will understand very, very quickly, and the other method is a little bit shorter of a method, but it makes it, you have to have a better understanding of exponents, I should say. All right. So with the quotient property, the question that I'm always going to ask you at the very beginning is how many things are you subtracting, or how many things are you dividing by? So in this case, I'm subtracting by two things. Since I'm subtracting two things, that means I should be dividing by two things. Now the same exact thing is true in the opposite direction. If I'm dividing by two things, I should be subtracting by two things. These properties should work the same exact way. So since I'm subtracting by two things here, I should have two things being divided by at the very end of the problem. All right. So that being said, what I would do if this were me, I don't like dealing with negatives. Since I don't like dealing with negatives, I will factor a negative out of the entire thing. Okay. So I would actually take a negative out of each of these and then put those two things in parentheses. You remember how the last example we went through on Friday, I put things in parentheses and I said overuse your parentheses and then we had to distribute the negative through? That's the same thing I'm going to do here, except in the other direction. All right. So before we do that though, I'm going to use the power property just to make sure that I don't make any mistakes with that. So this will turn into log base 4 of x minus log base 4 of y squared minus log base 4 of z to the third. All right, so I have something that looks like this. That should be a step that everybody gets, no question, no problem. The hard part is going to be with the subtraction. The subtraction is going to be the issue. What I do here is I take this negative and this negative and I factor them out. So I'm going to do log base 4 of x minus, and then I'm going to put a big set of parentheses, log base 4 of y squared plus log base 4 of z to the third. Yes?
Is that first one a y or is that a 4?
Where?
The
Right here?
No, down a line. No, the left and the first log.
This is a 4.
Oh, okay.
All right, so if you notice, all I did was factored out a negative, right? I have not really changed the problem at all, but I factored out a negative. And now as we run through, you can see that it makes sense to do the power, the product property before we do the power or the quotient property, right? So now we're looking at things for multiplication, and I can see right here that there's an addition sign, which means there's going to be multiplication here. So I'm going to end up with log base 4 of x minus, those two things will end up being multiplied. So it's going to be log base 4 of y squared z to the third. And now this is exactly like the problem that we just ran through before this one, where we had a little bit, or we had two things being subtracted. So it was only a little bit of subtraction, which made it much easier. When you have a lot of subtraction, it becomes challenging. When you have a little bit of subtraction, it becomes way easier. This is two things being subtracted, which means that there's going to be a division symbol. So I have log base 4 of this one divided by this one. So it's going to be x over y squared z to the third. Now that's one way of doing this. There is another way of doing this that I'm going to show you that hopefully makes sense too. And you can choose whichever one you want. Yes, Sean?
Do the in between the steps matter?
Not really. So I don't really care if you don't show me your work in between, because in all honesty, I would skip a lot of steps here too. Like I'm at the point now where if I see the first one, I can probably get to the answer without writing any of the other steps down, because I'll just do one at a time and I'll do them in my head. But if you're not good at this, don't skip the steps, right? If you're going from first step to last step and you're getting 100% every single time, that's phenomenal. If you're going from first step to last step and your answers are completely off and I can't tell where they are, you are not going to get any points. All right? I can't give any partial credit if you don't show me any steps. And that was something that I saw in the quiz a lot of. A lot of people did not show all of their work. They just wrote an answer down because I said you could do that, but I can't give any partial credit if I can't even see which equation to use. Same exact thing is happening here. If I can't see what's happening, I can't give you your credit. All right? So the second thing, or the second step that you could use could look like this. Second option is, instead of instead of distributing that power right away, I'm also going to distribute the sign with it. So instead of just distributing the 2 and the 3, or raising, I guess, using the power rule, instead of just doing that, I'm going to take the negative sign with it as well. So this will end up getting brought up. This will end up getting brought up. Some of you can probably already see the steps that that's making. So this is going to be log base 4 of x plus log base 4 of y to the negative 2 plus log base 4 of z to the negative 3. Now, before you ask, this is literally just another option of what we just did. So if this is something that if you understood the last one, you don't want to learn a new method, then shut your brain off for a second. If you want an easier, shorter method, this is your easier, shorter method. So right here, you notice that it is all multiplication now, right? It's all addition, which means it's all multiplication. So this will turn into log base 4 of x, y to the negative 2nd, z to the negative 3rd. And what happens when we have negative exponents? Where do they go? To the bottom, or the opposite of where they currently are, right? So in this one, I have a y to the negative 2, z to the negative 3, which means it's going to go to the bottom. So this will turn into log base 4 of x over y squared z to the 3rd. So this one only took one real step to get there. Other ones may take 2 or 3 steps to get there. Some of you might be able to do this without even looking at it. It is what it is. You choose what makes sense to you. That is the final answer, yeah. So your question, your checks for these are, if you are doing expanding happens when you are trying to take one log and make it as many logs as possible. Condensing happens when you take as many logs as possible and you try to make one log out of it. All right, so we're going from one to the other or back and forth. So make sure that you understand what condensing means and what expanding means. Okay. Now the last thing I want to show you is the change of base formula. This is how you can use your calculator. So on your calculator, check right now, because if this doesn't apply to you, then you don't have to do this. On your calculator, I want you to hit the math button, and I want you to start scrolling. So hit the math button and start scrolling. If you see something that says log base or something like that, then you are good and you don't need to worry about this.
I have no log.
But I'm going to scroll, and I'm looking to see if I see something that says log base, and I don't think I do, because I've scrolled through twice now and I don't see anything that says log base. I think it's under the alpha key, is that right?
Yes.
Is it right under solver? So if you have the change of base formula, that's great. When you hit that, it will open up. When you hit that, it will open up something that looks like this. And you put your base in and you put your other thing in. That's great. So some of you have that, some of you don't. If you don't have that, that's a bummer. But if you don't have that, there is a way that you can get around it by using a change of base formula. Whatever your formula is, or whatever you are given, you take the log of the big thing, or the first one, and you just hit the log button and you divide it by the log of the other one. So you take log of the one that's the bigger number and divide it by whatever the base is. And I'll show you what this looks like in an example. I will also give you this formula on a test, because it's a bummer that some of you have it and some of you don't. Okay, so I will give you this formula on a test just in case. So log base b of m is equal to log m, and I just mean the log button on your calculator. So it's log base 10. So log base 10 of m divided by log base 10 of b, right? So what this looks like is, if I asked you to find log base 5 of 25, then what you're going to do is you're going to do log of 25 divided by log of 5. Now be really careful with this, because if you are not using parentheses appropriately, or if you are, I guess, not putting things in order of operations correctly, you're going to end up getting bad answers. So just be careful with this. So when I try this, I would try log 25. So log 25. And I like to do this. When I do these, I actually like to hit the enter button so that I know I'm not running into any issues. Divided by log 2 or log 5. And then I should get 2. And the reason is because it's asking you how many times do you multiply 5 by itself to get 25. So that should make sense. Okay, so from now on, if you see anything where it says solve the log and it gives you a question like this, you just type it in your calculator and hit the enter button. Okay? These most of the time don't have to be exact. So whatever your calculator spews out at you with decimals or whatever, then you're good with that. Okay? Questions that you guys can think of right now? So that is the end of section 6.5. We will start section 6.6 tomorrow. If you have any questions, make sure you let me know.
Do you have an average velocity?
I can tell you.